Thank you, Emma, for hosting me today, and thank you all for attending this meetup. I know it's after working hours, so I hope I won't bore you too much. Thank you for some adjustment. So today I'm going to speak about Python and Postgres, but I'm not going to talk about how to connect Python with Postgres, how to make a nice application with Python, which uses Postgres as its database engine. Today I'm going to talk about horrific things, how to make an amalgamation of these two magnificent tools. So let's dive in. A short introduction about me. I'm Vladimir. I'm a full-stack software engineer at DataArt, and I've dedicated greatest years of my life to the software engineering. That's a very dramatic introduction of me, and it's an awful journey. If you are a software engineer, in some case you had very low days in your life, hoping that this industry might end during an apocalypse or something else. So personally, I don't like when someone speak about technology without showing some code or configuration. For example, scrolling documentations, pages of documentations without seeing anything real. So today I'm going to show you code. I'm going to show you a lot of code and few slides, only a few slides, and maybe this one is the main slide here, which just presents what are we going to analyze today. So we have a PostgreSQL database server here, we have a Python binary, so Python interpreter, and the small bridge here, which is called PL Python 3U, which connects the PostgreSQL to Python. To be correct, it integrates Python interpreter into the core of Postgres, and we will see how we can use that interpreter and what we can achieve, what horrific things we can do with it. Okay. So by using PL Python 3U, we can access the Python standard library, the whole side packages, third-party packages, and we'll see everything. The U stands for unmatched, or maybe unprecedented, or a lot of nice things you can think about Python. But honestly, it only says that it's untrusted. Okay, so we have PL Python 3 untrusted. PL Python 3 is a standard PostgreSQL extension. So there are many PostgreSQL extensions. One of the greatest powers of Postgres is its extendability. So you can extend it, you can just add a small extension to it and make it one of the most used time series databases. And I'm talking about timescale.db. Or you can add another small extension called PGCrypto and have all cryptographic utilities inside your database. But today we're going to talk about PL Python 3U, and I want to mention that PL Python 3U is developed, is shipped with standard Postgres. Okay, it is developed alongside Postgres, so you don't have to do anything else to have that extension. You need just to create the extension with a standard SQL query, and it's there. And of course, you need host installed Python to speak with Postgres. Let's now jump to our examples here. Here I have PSQL started, and I'm going to show you some small examples, from a smallish example to unbelievable ones, I hope. Let's start with the simplest one, and I'm going to show you this SHA3, okay? I'm going to create PostgreSQL functions with Python body in it, okay? Let's just imagine that for some purpose you want to have SHA3 algorithm inside your Postgres. Maybe you want to compute some hash of a column or make it a default value, whatsoever. But PostgreSQL for now doesn't have SHA3 available in it. Of course, you can install a PGCrypto extension and have it nicely, but not today, because today we have PL Python 3 extension and PL Python language, and we can just declare this SHA3 512 PostgreSQL function and use it inside our Postgres. We'll see how we can achieve it just in a minute. Okay, I have this function here. I can just select it and call SHA3 512 and compute a hash of some string. Okay, here we have this whatsoever, and I'm going to execute this. Okay, I have SHA3L computed on my input string. So with these few steps, just a few steps, there is an SHA3 inside the Postgres without any third-party extension, and then, meaning that it isn't shipped with PostgreSQL natively. Be careful with any cryptographic primitives. Please contact some person who knows how to do cryptography, because a lot of software have vulnerability inside them because of misused cryptography. Okay, that's why the next example is another cryptography example, which is horror for any security expert here, because I'm going to import Fernet. First of all, I'm going to show you the example, and then we'll see the code. So, and I can encrypt something. Fernet encrypt. I have these two functions here, and I can give my message here. Hello. Sorry, I'm going to do it again. So here is some gibberish, and we don't know whether it is encrypted or just output some random values here. And the only way to check this, whether this works or not, is to decrypt this gibberish. Okay, and I'm going to use Fernet decrypt here, decrypt, and we'll see whether it decrypts my payload or not. Just a small nudge here, and yeah, I have an encryption. I have a symmetric encryption here. And we can see here, if I just open this example here, I have two functions, okay? Fernet encrypt and Fernet decrypt. I'm using Python's cryptography library because I don't want to do cryptography myself. I'm too dumb for that. I'm using third-party Python's cryptography library, which provides me with this primitive called Fernet, which actually uses AES 256 algorithm, symmetric algorithm for encryption. And I encrypt a text, a plain text, with that, returning another plain text, which is the ciphertext. And I have a Fernet decrypt, which decrypts the ciphertext, okay? Please be very careful when storing your key, whether it is symmetric key, asymmetric key, because the leaked key here can lead to vulnerabilities. Anyone will be able to decrypt your payload. Encryption will lose its meaning here. That's why I've done here the super secure location here. This is the most secure location by me, okay? That's why you don't have to trust me. Ideally, you want to use something like HSM, okay, hardware security modules, or please contact anyone who knows better how to manage secret keys. Or if you leak your key, feel free to refer to me and tell that I have told you to put your secret keys there, okay? I'll take that. But just returning to this small example here, if you manage your keys securely, you can, by creating these two small functions, use encryption inside your PostgreSQL. Okay, you can store that data encrypted by triggers, or you can use post insert triggers or before insert triggers, whatever you want, and have encrypted data. And you can select the data already decrypted from PostgreSQL. So pay attention here, I'm not encrypting my data inside my application. No, my application doesn't know whether this data is encrypted or not. My application just sends plain text to the database. It says insert this data into the table, okay? And then some magic happens here. It encrypts using, for this example, symmetric encryption, and it stores inside the database encrypted data. And if someone steals that data, they need also that private key for decrypting this data, okay? So this is a very nice example showing that only with small amount of code we can achieve some nice things inside PostgreSQL. Of course, the PL Python is not the only way to achieve this functionality. We can use PGCrypt extension, which gives us different encryption algorithms. But I think this just seems nice. And of course, if you know Python, and you can use this. Okay, let's dive to another example here, which is, I think that first I thought I may skip saying AI during this talk, because there is too much AI in our world, and I don't think it's an AI. I don't like when people refer to these nowadays technology as AI, but I don't have, I can't just spread my opinion here. That's why I'm going to show you AI here, okay? But some small sentiment analysis, and I'm not telling that that is AI because that is just statistics. I'm going to load something called sentiment analysis, okay? And I'm going to load this, it will load, and I'll show you what just happened here. Just a minute. So I have this small data here, the reviews, okay, where we can store user reviews. I have email here, review text, I have a reaction, whether that was a positive or negative review, I have a polarity of that reaction, and created data, okay? And now let's dive into how I collected this data or reactions. Okay, I have this sentiment analysis here. Let's see how I insert the data. When I insert data, I only insert the email and review. The review from that person. I don't insert any sentiment for that review, okay? What happens is the magic created by combining Python and Postgres and Python's ecosystem, okay? I have created this small function, first of all, the table, of course, which is nothing very special, and here is the function analyze sentiment. After which I created another trigger that is called tg analyze sentiment, and I put this, jumped, and I said that I want to execute that trigger after insert or before insert or update on my reviews, and execute for each row. What happens is another magic, as I can integrate PL Python language with PostgreSQL transactions. Okay, I can control transactions with Python within the Postgres database. And by using this small library called TextBlob, which uses statistics, not artificial intelligence, not machine learning, okay, that is capable of integrating some ML algorithms. I do here just small sentiment analysis. I called the TextBlob and pass the review to it, and very dumb comparison whether polarity is greater than 0, then it's positive or negative or neutral. Of course, experts here can say that this is a top-down way to analyze the sentiment, but of course you can replace this code with actual sentiment analysis using machine learning algorithm or other sentiment analysis, statistical models, whatever, and you can get more accurate reviews or some insights about your data here inside your database. And when the data arrives into your database, you have already computed some necessary information about your data, whether it is sentiment, whether it is in encryption, whatsoever. And you know that there are tons of libraries to analyze text, to compute some information, have insights. Maybe you want to compute tokens or vector embeddings for this. And without PG vector extension, for instance, just for computing vectors, you can use some Python library and compute the vector embeddings instantly here, or maybe with after update or after insert triggers, you can insert those vectors into another table. Okay, this opens tons of opportunities. So whatever you imagine, it's possible. If you can write that Python code, that code will run inside this transaction. Okay. So after jumping from this example, I want to show you another one, which I call remote tables. Okay, so let's execute it. Remote virtual tables, and we'll see some output here, and I'll explain what that output means. I have here a regular table, which is called USA states. It just has an ID generated integer and a name. Okay, nothing serious. And I inserted some states here: Washington, Florida. Nothing special, just a randomly picked them. And I have here another function which is called USA state weather. Just skipping this function's body, I want you to pay attention to this query here. Okay, select from that function here, limiting to 10. Okay, I am selecting from a function as a table. So this is a dynamic table, and I can collect the data for that table dynamically. And what I'm doing the worst thing that a person can do in a database. I'm doing a network request here. Okay, I'm just fetching the data, the weather data from some resource. I'm creating the dynamic table here with the city, the state, temperature, whatsoever, and I'm returning the data. And I can execute this query, and we'll see that it will return the result. So it's just making a network request, that's why it is so slow, okay? Remember that doing network requests is slow and unsafe. So please don't do it inside your database. Of course, when there is a rule, the first thing a person does, a programmer does, breaks that rules. That's why I'm breaking the rules, and I'm going to break that rules in our production. My CTO is sitting right there. So I'm going to break that rule, and I'm going to update our tables from the network.
If you have a CTO after this.
Yeah, thank you. Back to the code here. I'm fetching the data and generating dynamic table here. And the best part that I found myself was that I can actually join with that table. So I can select from my physical data, which is right there in my database. And then I can join it with some network resource. If I can describe that network resource as a relational table, then I can join it with that table. I didn't find any other extension that is willing to do this. I think it's the worst idea that you can do in a relational database. That's why there is no such extension, and I hope I'm the first person who have ever joined to a network a relational table. That's too much to ask for, but I hope so. So here is the last part, which, okay, I'll open it. I have here inner join, USA States, weather, and I'm just comparing this part. So this was just available here because I can make network calls with Python, of course. I can create a generator, or I can also yield a return list here, and I can declare a dynamic table using Postgres. So this integration is fantastic. Okay, I just can't imagine my excitement when I found this. But this is not the most stupid thing I can do it with PL Python, okay, with Postgres and Python. This is not the end. Can you imagine what I have done here? Not this example, the next example, maybe. Okay.
Something like aggregating function.
Sorry?
You can do something like aggregating function or maybe window function.
Yes, right. But I think that's more sane thing to do, and I have done an insane thing. Okay. Do you know how Python? Okay, I'll just spoil myself, and I'm going to import PostgreSQL, and I'm going to call HTTPD on a port 1990. Okay. This thing I hope is running. Just a second. Wait a minute, I hope it runs, and after that you come on, it's not running. Just a minute, please.
Just open next terminal.
You mistyped the address.
Maybe your browser just took to
Yeah,
host.
Thank you, the demo gods, live coding gods, who were punishing me for this example, but here is the running example. I love PostgreSQL. So I just run a web server inside the database. So I'm running an operating system in which I'm running a Docker container, in which I'm running PostgreSQL server, in which I'm running Python. And inside the Python, I'm running an HTTP server. A crazy thing, yeah? Let's analyze a code of this thing. And first time I've done this, I've crushed everything because of this tiny small thing. Now let's analyze the code. There's nothing too special because here is the WSGI application, the minimal application which yields hello world from Postgres. And I have here this make server which creates the actual server, it receives the port number. And here is the main pain that I got. I have spent tons of time here. When you don't register any signal handler here, you can't kill this process. Whether you just terminate it in Postgres, or maybe you call PG cancel query or PG terminate query, it won't terminate that process, and you will have an HTTP server running forever. Because when you send a signal here with Control-C or some other tools, the Python just, if you didn't register any signal handler, that Python will ignore everything. So I don't understand that. So I run indefinitely. I'll run your web server inside your Postgres indefinitely. You have to kill that Postgres process to kill me. Because actually that Python process is running inside a Postgres connection process. You must pass everything that Python process receives, Postgres process receives to the Python. That's why this part is crucial to create a signal handler, which I've just exited the code, maybe you want to do something else, you want to pause your Python HTTP server. I don't know why you would like to pause your HTTP server inside your Postgres, but maybe you want to pause it. So I've just killed the Python process, that's why I'm able to terminate this, okay? First, I thought, when preparing this talk, I thought that that's it. Okay, this is enough. Harassing Postgres with Python, that's why I thought maybe this is enough, but no. The next example is also web related. There's nothing too much new, but I thought if I can run a web application here, can I create a web shell for Postgres inside a Postgres? And let's see if it's possible or not. So I'll call web.
I feel you have succeeded.
To call web SQL shell, and I'll run it on the same port number here. Hope it's running. This is a shell. So, do you remember that I had the table before, which was called reviews, so I can select all from reviews. I think there was something like this. Let me zoom out a bit. And I have a web shell inside my Postgres, which does almost the same thing as PSQL. Okay, I even have some autocomplete here. This is a security nightmare, okay? You're just running untrusted code inside your database, which exposes some web functionality to a user, serves some shell here, or whoever has access to this can do anything. But just coming from another perspective, this can serve a lot for debugging purposes. This shell here, this terminal, is a totally controlled environment. This is just same WSGI application, which just serves HTML and does some comparisons here, okay? You can expose just the minimum amount of functionality here to developer or administrator, whoever you want, and not give that person access to your database through an administrative tool like pgadmin or something else. You can say, okay, you know what, you want to analyze the data or maybe troubleshoot something. Here is a shell which you can only select something or maybe update something. Of course, update is changing your data, but maybe you want to just select something. So this has some use cases, but of course there are caveats, and please be careful. Don't think that I understand what I'm doing here. Don't take my word as granted. Please contact some security experts, maybe some help from your colleagues. But these things demonstrate the strength and opportunities that you can use Python inside your Postgres. Okay? These were the examples here. I want to sum up somehow, if it is even possible, and I want to just sum up the advantages and disadvantages of these things, okay? So the first advantage of being able to integrate Python inside the Postgres is just giving access to Python's vast ecosystem from PostgreSQL. You know, there are tons of libraries. Maybe Python is slow, maybe there are some problems with package managers. I don't remember exactly who told, maybe there are words of source too, but he told that there are two languages, one who everyone complains about and the other group who nobody uses. So of course Python is not the best tool for that, or some people say that Python is the second best tool for everything. But it has vast ecosystem, and there are tons of libraries for security, networking, analysis, anything, you name it, okay? And you are just giving access to your programmers, giving access for that ecosystem to your programmers. And another advantage, I think that is very powerful advantage, and number one for me, that your data stays locally. Okay? You are not sending your data for encryption, you are not sending your data for analysis. If you are able to run, for instance, the machine learning models next to your PostgreSQL database, you may feed the data to your Python process, to the processing tool, and not send your data anywhere, regardless whether that anywhere is your application or third-party application or whatever. So it's a very privacy-oriented thing to have. Also for performance, because keep data locally to your computing. That's motto when you want to achieve performance, when your data is close to you. So staying inside the database, having that integration will yield to a lot of good things in good hands. Okay. Also for rapid prototyping, maybe you want to just quickly test some hypotheses, and there are libraries for that. You want to build some quick functions, maybe to rewrite with proper extension or proper C code there. So you prototype with Python, which Python is very good for. Also, you can use your existing Python knowledge in that, and it has very great integration with Python, with Postgres triggers and transaction management. From the worst parts is the performance, okay, because you're paying penalty for casting data from one type to another, from PostgreSQL types to Python types. But PL Python 3 UE extension does very good job and it transfers everything. So kudos to PostgreSQL developers who do amazing amount of job to handle every Python version coming, and also to increase the performance of these integrations. PL Python U exposes untrusted language. So you know that if you can run Python script, you can access the operating system, network, whatsoever. Any harm that can do standard Python script within its permissions on the operating system can do also the stored procedure, which uses PL Python as its language. Okay? Of course, deployment challenges. Besides Postgres, you must have the proper version of Python on your host to integrate with Postgres. Also, it may be harder to debug because you can't just attach a debugger to your running Postgres, Python code inside Postgres. Of course, you can come up with another disadvantages based on your thoughts or your experience, but I think that these are the sum up of them all. I think I have time here to just show you another thing here. I want to speak about my slides here. I don't know if you noticed, but these are running inside PLSQL, okay, the PostgreSQL concept. This is a terminal. This is a real terminal, and I for several talks, my public talks, I've been using this tool called ThermoSlides, which transfers the plain text to slides. These are the same slides with that tool here. Small tool, just one Python file without any dependencies. And I thought that, okay, this is cool, but this is not a Python meetup. This is an PostgreSQL meetup, and damn me if I'm not running my slides inside PLSQL. Okay, so this is it, guys. Thank you for listening me. Thank you for staying with me so long. Thank you for not throwing anything on me after these horrific examples. And select your questions.
So, if I understand you correctly, you initialize Python interpreter inside the PostgreSQL worker process. Am I right?
Yes.
Okay. This initialization happens every time, or this is once time? So what about a global state of this Python interpreter? I mean something like model states, local hashes, local variables, etc. What about global context of this Python interpreter?
Very good question, thank you very much. So every PostgreSQL function that wraps Python code has its access level, its scope. So there is no such thing as Python global scope inside each function, but PostgreSQL exposes some primitives like session dictionary, transaction dictionary, and global dictionary, which can be used to share data between single session, between functions in a single session or in a single transaction or global state. So if you want to share data, persistent data inside PostgreSQL for different function invocations, you can access those dictionaries, those globals inside Postgres and store your values there.
Okay, so imports execute every time, yes? This is performance overhead if your modules have initialization code and this code take some time.
Actually, that part is handled by PL Python, so it tries to load the interpreter and make the isolations. So when you're executing your code, the scope of your code's access is limited to a function, a PostgreSQL function, but managing the interpreter when it must be restarted or shut down or something else, or is handled by PL Python 3 extension.
Okay, and the last question I didn't see. Can we implement on the PL Python aggregating function, not only simple functions without side effects, because I think it's most usual use case, but something more complex which allow us work with not only one row inside the data set, inside the Postgres, but with multiple rows as batch, for example.
I didn't actually look at that point, so I think that creating a window function requires poking more inside the PostgreSQL internal. So I'm referring to PostgreSQL documentation, the official documentation of PL Python, and there is nothing close to what you are demanding here. I have looked through the window function implementations in native PostgreSQL and other extensions that are providing the window functions, and I've seen that they're integrating with C interface of PostgreSQL. That's why I don't think that for now it's possible, but as PL Python 3 is an extension, maybe somehow we can open feature request that will expose those functionalities, the window or aggregation related functionalities, to ease development of such functions. Thank you.
Thank you.
I've got a microphone. Can I ask you a question?
Yes, sure.
I'm not going to. So I was thinking, like another horrific example. Maybe as PG admin 4 is written in Python, maybe we should run PG admin inside PostgreSQL to not have external dependency or running processes. You should try that.
Actually, PG Python 4 is a huge application, but I think it's totally feasible because I didn't manage to connect to PostgreSQL from PL Python using PsychoPG, so I was running a PL Python function, which of course has access to PostgreSQL, but I connected to the same Postgres using PsychoPG. So I think it's
You
possible.
have done it? You have done it?
Just yes, I've created a connection, but not PG admin.
Okay. you.